Last December, a fatal outdoor accident in Nanchang. A boulder fell in Meiling, trapping a climber. I found footage shot before the accident, trying to piece together what really happened. Here's the setup. A climber was rappelling down. Then things went sideways. The rock holding the rope got pulled loose. The climber ended up pinned. This rock was on a popular climbing route. Boat-shaped rock. About 1.8 meters long. Estimated weight -2 to 2.5 tons. Normally, on a 20-degree slope, a rock that heavy, a few people couldn't budget. But one person's pull brought it down. Why? The rock was wedged in a V-shaped groove. Let's simplify. A level V groove. A stick placed vertically, solid. Placed at an angle, it rolls. Not always. If it's rubber, it might hold. It all comes down to whether the friction at the contact points can hold it, keep it from turning. Back to the scene. Before the accident, the rock looked stable. Deceptive. This footage is from a few days later. Two main contact points are visible. Left one slightly bulging. Right one. Draw a line between them. That's the problem. The rock wasn't just sitting crooked. Look at this point. The blue arrow shows which way it wanted to go. Measure the slope in that direction about 35 degrees. The contact point itself around 40 degrees. At that angle, the rock could have slid on its own. But it didn't, just barely balanced. A couple tons? Human forces can tip that balance. So if the rope pulls aligned with that direction, no surprise it gave. Scrape marks are there. No sign it was about to tip into the groove. Set that aside for now. Sometimes, a boulder that size 1 or 2 people can actually rock it. Rock spanning the V groove to points of contact. Think of a pendulum. Not that dramatic. Walk on it, you wouldn't feel a thing. But pull sideways with enough torque? It sways. Turning and swaying loosened it to ton rock. Then pulled 30 to 40 centimeters. Right end slipped first, it fell. That last stretch just dragging along the groove. V groove angle about 20 degrees. Normally, pull a 2-ton rock down a 20-degree slope, not gonna happen. But after loosening, contact points shifted. Here's the thing, the contact area is tiny. For this rock type, 2 tons, contact patch may be the size of a fingernail. Zoom in on that new contact point. Grains and edges crushed into powder. Loosening turns static friction into kinetic friction. Now with powder, friction drops from around 0.7 to 0.3 or 0.4. Suddenly, one person can pull a 2-ton rock down a 20-degree slope. Pull after pull, more powder grinds out. Heavy enough, drag it half a meter, it slides on its own.